Hello, you lovely people out there. Today I'm going to be teaching you how to make a solar cell using mostly common household items. Let's get started. So the first thing you're going to do is collect all of your materials. What you're going to need is some sort of dish. Any dish will do. A tea light. Some alligator clips. Blackberries. Iodine, a paper towel, some conductive glass, which I will be telling you where I got from shortly. These actually came from a control box from my dad's work. Glass from a touchscreen. A voltmeter and a blender, which is not in view of the camera right now, but that's okay. I'm pretty sure you all know what a blender is. Alright, let's get started. And then also that thing that I forgot to mention, which is very, very important, which is sunscreen, because you're all gonna get skin cancer if you don't put it on. No, I'm kidding. Sunscreen, because it contains titanium dioxide, which is actually very, very hard to come upon these days in the sunscreen form. Who would have thought? You can also get it in a powdered form usually, because they use it for whitening cake mixtures, and some painters use it. I couldn't find any, unfortunately, so sunscreen. So you're going to take your voltmeter, which measures resistance, and you're going to see which side of the glass is the conductive glass. As you can see, there's clearly resistance going through it because my body is very resistant. Not very resistant, actually. You're going to take both of the probes and you're going to place it on one side of the glass. This is measuring about a little bit over 1,000 ohms. I'm going to take and measure the other side, which our glass is flipped to the other side. You're going to see that its resistance is infinite, which is why it's measured at 0. So the instructions that we're using use a glass made out that has a tin dioxide coating on it, which measures a resistance of about 10 to 30 ohms. As you can see, our touchscreen glass has about 100 times that. So let's see if this actually still works. Next, you're going to take your tape and tape 3 of the sides. Next, you're going to take your sunscreen and put a layer on it. You take your ruler and you're going to kind of smooth it out. Then go back and cover everything that you missed, like I did. Once you have a relatively thick film, you're just going to leave it there to dry for about 10 to 15 minutes. After that, remove the tape. Blend it until you have this nice looking juice. Alright, so next you're gonna untape your dish. And then you're gonna take your nice and clean dish, pour a little bit of that juice in it. Left to soak in. Next, you're gonna take your dish, put the white sunscreen, put it face down, and soak it in there completely for about 5 to 10. Did not mean to push it. Do not push it down. My finger slipped. For about 5 to 10 minutes, or until you can no longer see the whitish purple of that don't push it down. While the other slide is soaking in the juice, you're gonna take the other piece of glass you have and test for the conductive side again. Once you've determined which side is the conductive side, make sure you're holding the glass in something that won't allow it to transfer heat easily to your hand at least, so you don't burn yourself. Like this towel we are using. After that, you're gonna light your candle and carefully hold the glass over the flame with the conductive side down. Now what this is doing is depositing carbon on it. As you can see it turning black, you're gonna do this until it's all black. You don't wanna see any more traces of translucency in the glass. Please be careful to not hold the glass too close to the flame for the entire time, or it will break and shatter in your kitchen, which is kind of dangerous. Make sure you leave a gap where there is no black, like where your hand is holding it, because that's where we're going to be attaching the alligator clip. Alright, when it's done, it should look like this. Like that. Alright, so now it's been a little while. We are going to pick up the glass very carefully by the edges. I forgot the sharp side, gosh darn it. So if yours turns out a failure like mine, and there's sunscreen dripping into your blackberry juice, you can always try the alternative, putting it in the oven to dry the sunscreen first, if you have safer glass. Or you can do what I do and hope for the best by putting it in the oven now. As you can see, it's turning a very dark looking purple. Then you have both your sides complete. You're going to carefully take the black carbon coated side and match it on top of the blackberry and TiO2 side, offsetting them intentionally to leave a little bit of space for the alligator clips. Next, you're going to take your binder clips and clip the two plates together carefully. So once you have your plates together, you're going to take your iodine and be very careful because it does stain. An eyedropper, if you don't have an eyedropper, I'm using a straw actually. And you're going to drop it on one of the edges. And through capillary action, it will be drawn into the plate. Now that you have it completely filled with the iodine, you're going to take your negative terminal and attach it to the TiO2 coated plate, the alligator clip, and then to the negative terminal of the voltmeter. You're going to take the positive terminal and attach it to the unburned section of your carbon coated one and attach it to the positive end, and make sure that you switch it to the volt. And the moment of truth is that there is some degree of power in it. To get a basic understanding of how our solar cell works, we need to know how all solar power devices work. Basically, an incoming photon from the sun boosts the electrons in a semiconductor state where it's mobile and therefore can produce energy. TiO2 in this case is the wide bandgap semiconductor. However, this gap is so wide that the energy from the sun can't excite the electrons enough to make them conduct. But it can excite the electrons in the blackberry dye on top of the TiO2. These excited electrons transferred from the blackberry dye to the TiO2, which is then transferred to the electrode and produces energy. But this leaves the blackberry dye oxidized, and therefore it needs an electron to make it neutral again, which it gets from the carbon Because the carbon-coated plate is not physically in contact with the BlackBerry die, we used iodine as a sort of bridge to transfer the electrode from the carbon to the BlackBerry die. The TiO2 is an electron acceptor and the iodide is an electrode donor, and the die is a photochemical pump that excites electrons to a conductive state. The resulting voltage across the cell is the difference in energy between the redox potential of the electrolyte and the conduction band of the TiO2.